In this video, we're going to talk about double angle identities. We're going to look at the three formulas and then some examples. If we double an angle of measure x, the new angle will have measure 2x. So if we recall, sine u plus v equals sine u cosine v plus cosine u sine v. So here, if we're talking about an angle sine of x, and we want to look at sine of 2x, this means that we're actually just doubling x. So instead of having u and v, we're going to have x plus x because they're going to be the same angle measure. So if we have sine of x plus x, this is going to turn into sine x cosine x plus cosine x sine of x. So now I can just add these two together and I'm left with 2 sine x cosine x. And this is going to be our very first double angle identity. Sine of 2x equals 2 sine x cosine x. Okay, so here is that first formula that I just derived. We can find the other two, tan of 2x and cosine of 2x, in a similar way as we did the sine identity. In order to get these two equivalent expressions for cosine of 2x, we can add sine squared of x or subtract cosine squared of x from the double angle identity for cosine 2x and use the Pythagorean identity to derive the other two forms. But I won't cover that in this video. So now we're going to look at an example. Given that cosine x equals 5 over 13 and x is in quadrant 1, find the exact value of sine 2x, cosine 2x, and tan of 2x. Then determine what quadrant 2x lies in. So knowing that in order to use the formulas I had listed on the previous page, I'm going to need to know all three sides of my triangle. Here I'm given cosine of x equals 5 over 3. And from SOHCAHTOA, I know that cosine is adjacent over hypotenuse. This is going to allow me to figure out the length of the other side of the triangle. So using the Pythagorean theorem, I'm going to have 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. And this is going to give me b squared equals 144. So now I know that the other side is going to equal 12. Okay, now that I have all three sides of my triangle, I can start by finding sine of 2x, which from the previous screen is 2 sine x cosine x. Sine of x is going to be opposite, which we just found to be 12 over hypotenuse, which is 13, times cosine x, which was given 5 over 13. Simplifying all of this, I'm going to get 120 over 169. And that's going to be the value of sine 2x. Now I need to find cosine 2x. I'm just going to use the first equation, cosine squared x minus sine squared x. Again, cosine x was given 5 over 13, quantity squared, minus sine of x, 12 over 13, quantity squared. Simplifying this, it's going to give us negative 119 over 169. And that's going to be the value for cosine of 2x. Then last we're asked to find the tangent of 2x. From our formula we have 2 tan x over 1 minus tan squared x. So here I need to know what tan of x is, and we haven't found that yet. But the last part of SOHCAHTOA says it's opposite over adjacent. So now I have 2 times tan x, so I have opposite 12 over adjacent 5 divided by 1 minus tangent squared. Simplifying this, we're going to get negative 120 over 119. However, I do want to mention that there is another way that we could have found tangent of 2x without using this formula. Tangent of 2x is also equal to the sine of 2x divided by the cosine of 2x. This is related to earlier when we said that tangent equals sine over cosine. Well, since we're just doubling our angle, it's also equal to sine of 2x divided by cosine of 2x. Since we already found sine of 2x above, I have 120 divided by 169. We also already found cosine of 2x, which was negative 119 divided by 169. Whenever I simplify this, I'm going to get the same answer as above, negative 120 divided by 119. All right, looking at this next example, we have cosine theta equals 0.8660. Theta is in quadrant 1, and they want us to find the exact value of cosine of 2 theta. So here, since it's in decimal form, really the first thing that comes to mind is I wonder what my angle is. So if I take the cosine inverse of both sides, it's going to allow me to be able to solve for theta. And when I put this in my calculator, I'm going to get theta is equal to 30.0029 degrees. So we're at approximately 30 degrees. But it wants me to find it for 2 theta. So in order to do that, all I need to do is multiply both sides by 2. In doing this, I'm going to get 2 theta equals 60 degrees. So now, really what it's asking for is what is the cosine of 60 degrees? And looking at our unit circle, we know that the cosine of 60 degrees is 1/2. Therefore, the cosine of 2 theta is 1/2. In this example, I'm going to relate back to a previous video that I talked about simplifying and manipulating trigonometric expressions. So now that we have these new formulas for our double angles, we can now manipulate different trigonometric expressions that already have double angles in them. So looking at this example, I have sine alpha minus cosine alpha squared. So I'm just going to go ahead and write that out. And now I'm going to go ahead and substitute in 2 sine alpha cosine alpha, because that's what sine of 2 alpha equals. Following this out, I'm going to get sine squared alpha minus cosine alpha sine alpha minus cosine alpha sine alpha, and then plus cosine squared alpha. And I still have 2 sine alpha cosine alpha from above. So here I can combine like terms, and I'm going to go ahead and rearrange this and write my sine squared alpha with my plus cosine squared alpha together. So I get sine squared alpha plus cosine squared alpha minus 2 cosine alpha sine alpha plus 2 sine alpha cosine alpha. As you can see, these two terms are going to cancel. And if you remember from the simplifying and manipulating trigonometric expressions video, sine squared alpha plus cosine squared alpha is a Pythagorean identity, and it equals 1. So this big expression actually simplifies all the way down to 1. And that's it for this video.